Hey everyone, in this project I'll show you how to create your very own temperature controller using an Arduino board and some mLink modules. We'll break this project into two parts, with the second part being optional depending on how complex you want the controller to be. So in the first part we'll use an mLink NTC temperature sensor and an mLink relay module connected to a Arduino. In this case, the hardware components Uno Plus. You can use any Arduino compatible development board with this project as long as it's got a I2C port and can supply 5 volts to the mLink modules. I will link to the Uno Plus in the description below. So in part 2 we'll go ahead and add an mLink LCD screen so that the current temperature and status of the relay can be monitored without the Arduino being connected to a computer. This video does make some assumptions, so for instance that you already have a copy of the Arduino IDE installed and that you already know how to use it to program your development board with a sketch. So for step 1 you'll need the following: an Arduino board, as I said the Uno Plus is the one that I'm choosing to use, the mLink NTC temperature sensor, the mLink 1-channel relay and some DuPont cables. The cables that I'm using were basically stripped from a 40-way DuPont cable. These are 10 centimeters long, but we do sell 20 centimeter long cables too. Obviously the cables you need will depend on the headers of your specific development board. Finally, if you intend to complete the second of the videos, you'll need a mLink either 20x4 LCD or a 16x2 LCD. The project works with both, so it's personal choice. So let's remove the LCDs. So the first step is connecting the hardware. You'll need 2 sets of 4 cables. Because I want the connections to be consistent, I'm using black for ground and red for power. I'll go ahead and use green for the SDA connections and blue for the SCL connections. So let's connect up the relay to begin with. So one set of the cables, and we're doing ground is the black cable, red is the power, so plus 5 volts, and then we're doing green into SDA and blue into SCL. Now all we do is follow these, because we've figured out what colour we're going to use for each thing. It makes it slightly easier. So black into ground, red into power, and then green and blue. So green into SDA, blue into SCL. One thing about the Uno Plus is that the SDA and SCL pins are actually marked up, which makes it much easier. So that's those 2 connected. Now we need to make the same connections for the temperature sensor. So we're going to use the other header on the relay module, make the same connections, so ground, black, power, red, and then green and blue for the SDA and SCL respectively. And then this end again, black, ground, power, and then green and blue. So that's all the modules connected together. Now we can write the sketch. So our first step is to include the library. And now we're going to add a few lines to make the rest of the sketch easier to read by using descriptive text rather than hexadecimals. So this is the default mLink relay I2C address. And the default I2C address for the NTC sensor is 54. Next, we'll define two variables that we'll use to hold the temperatures. These are called set points. To set the default on temperature, we add float on set point, and we'll set that to 26 degrees. And similarly, for the offset point, float offset point, and we'll set that to 28. You'll want to change these temperatures to match the on-off temperatures you require for your application, and for testing you may need to alter them so that you don't need to sit for long periods waiting for a change to occur, hence them being set to 26 and 28 for this video. So now we need to add a global variable which will keep track of the current relay state. For this we'll use a boolean. And finally, for this section, we need to create an instance of the mLink library. For testing purposes, it will also be really helpful to know what the current temperature and relay state is. So in the setup function, we'll include the standard serial begin function so that we can output them to the IDE serial monitor. So let's first initialize the library. And then we'll include the function that I mentioned. So now we can start on the meat of the sketch. We'll start by reading in the current temperature and outputting it to the serial monitor window. So the first thing we need to do is get the temperature. So float temp equals get temp. Then we'll update the relay status. And then we'll print both to the serial monitor. And then let's add in a half-second delay. So now we need to declare what the getTemp function actually is. Each time we run this function, it will take 10 readings from the temperature sensor and return their average. This will give us a much more stable temperature reading than just taking a single measurement. So float getTemp So this function uses a for loop to run the mLink library's mLink ntc temp read command 10 times. Each time it's run, it adds the result to the temp variable. It then divides the sum by 10 to get the average before finally returning the result. And now we need to tell the IDE what we want to print to the serial monitor. So let's get it firstly to print the actual word temperature. And we'll follow that up with the actual temperature, and make that to 1 decimal place. Let's add in the centigrade sign. And the word status. The status will be for the relay state. We've not added this to the relay function yet, but we're about to, so add this and then bear with me. So if the relay state is on, we're going to print serial dot println on, else if it's off, we're going to print off. So before we move on, let me explain what we just wrote. The main loop will now call the getTemp function to get an average temperature, and will then store it in the variable temp. It will then call the printStatus function to print the new temperature to the serial monitor, and finally, before looping back, it will wait half a second so that we don't flood the serial monitor. You can increase that delay if you need to. The last step in this is setting up control of the relay. We need to add some logic to determine if we're controlling a heating or a cooling device. We can do this by looking at the on-off set point temperatures. If the on-set point temperature is lower than the off-set point, we can assume we're controlling a heating device. So for example, if the on-set point is set to 26 degrees and the off-set point is set to 28, then we'll turn the heating device on when the temperature is below 26 and off when it goes above 28. Conversely, if the on-set point is higher than the off-set point, we'll assume we're controlling a cooling device. For example, if the on-set point is set to 28 and the off-set point is set to 26, then we'll turn on the cooling device when the current temperature is above 28 degrees and off when it goes below 26. So we'll create a new function called updateRelay to contain this logic. So for the heating condition, we want to turn the relay on when the temperature is below the onset point and turn the relay off when it's above the offset point. So if onset point is lower than offset point, then run this. And turn the relay on. Else, if the temp is higher than the offset point, the relay should be off. So if that's not true, we want it to run a different set of code. So if we add in an else if statement, offset point less than onset point, and if that's the case, run this code. Turn the relay on, else if not, else if the temp is lower than the offset point, relay states should be set to off. So the last thing we need to add to the update relay function is to tell it to write the update a relay state variable out to the relay. We do this using the set relay function from the mLink library. So mLink dot set underscore rly0 relay address and relay state. So let's try compiling that. Oh, no issues. So let's go ahead and upload it. Pull up serial monitor. Right. As you can see, it's reading out the temperature and the status of the relay. Now, if I increase that temperature, can you see? So next time we'll be adding an mLink LCD to the mix, so hit that subscribe button so you'll get a notification as soon as it's released. Have a great day and I'll see you next time.